Hello and welcome back. In this video we're going to investigate parallel arrays and two-dimensional, three-dimensional, four-dimensional, or n-dimensional arrays. So you should have already watched the video on arrays before you watch this video. But let's review for a moment. If we assume this is our memory, this spreadsheet, each cell location represents one memory location. I have a object, or this more appropriately is called a data structure, called an array. We're going to call this an int array because we are going to store integers in this array. Note that integers can only store one type of data. That means you can't store doubles with integers with booleans. When you create an array, it must be all the like elements of the array. So there's only going to be integers in this array. And the index is how many locations away from the beginning of the array. So this array happens to be 24 locations big, from 0 to 23. So our int array sub 0 points to the first element, and int array sub 23 points to the last element, which happens to be the 24th element. So as you can see, we store just integers. If I attempt to store a string, like hello in here, that would be an error. And you would not be allowed to do that. The program would crash. So remember also with arrays, you have got to remember how big your array is. You don't want to go out of bounds. Out of bounds means you're trying to access memory that has not been allocated to the array. So this int array has only been allocated for 24 memory locations. If you're trying to access the 25th, 26th, 27th, that's considered out of bounds. Note that does not always cause a failure right away. So you can get in trouble with this bad because you can only access int array sub 23. You can't access int array sub 24 because it's out of bounds. But it does not cause an error. I'll show you an example of that later. We also have this concept called parallel arrays. So if you consider two arrays side by side, and in this array I have 25 elements from 0 through 24. So the index basically is a pointer to the names array and the grades array. So let's say I want to store the grades of all my students of the class. Well, let's say I have John. So John is a string. It goes into the names array, and his grade happens to be an 85. So we access the grades array sub 0 is John's grade for whatever it is, the test or the homework assignment. So Sue, we put Sue in here, her grade is a 94. So Sue's grade is, Sue is at index sub 1 and her grade is at index sub 1 also, and that's a 94. Let's say we have Daniel, and his grade happens to be a 84. So we have an index that is shared by the parallel arrays, two side-by-side arrays. Therefore, the element in the name array identified by index sub 0 and the grade array of that same index, they share a relationship. The relationship is grade sub 0 is John's grade. Now, so the names array should be strings. Now let's take this a step further. Let's say I want to store all the grades of all the tests and quizzes. Well, we'll just make 3 parallel arrays, and I will just color this to signify that it is another parallel array. So let's say the first column is test 1, the second column is test 2. So John's test 1 was an 85, and let's say his test 2 is 100. And Sue's test 1 is 94, and test 2 is 94. Let's say Daniel made a big mistake and he got a 50 on the second test. Now note, when you are coming up with the size of your array, I would always buffer that size by about 10%. So if I know my class only can hold 25 people, I would probably buffer my array size 3 slots just in case I get 1 or 2 sitting on the floor and I allow that. So be sure you always buffer your array size by about 10%. And the reason why you want to do that is your array, once you declare it, before you start running it, you cannot change it. It is called static. So the array size is static. You cannot increase the size once your program starts. So let's say we're down to the 23rd index and we're almost running out. Well, let's say we hit 25, we're technically out of bounds. So that is an error. So that is a talk about parallel arrays. Now we're going to talk about two-dimensional arrays. Okay, so here I've created a two-dimensional array. Let's call this board as a game board. This game board has 9 rows by 3 columns. So it's a funny game board. Think of a chess set. A chess might be an 8 by 8 because a chess board is 8 by 8. But my board is a 9 by 3. So whenever we want to address a particular cell on the board, it would be board, the cell where I'm on right now, it would be board sub 3 followed by 1. So this element here would be referred to as board three, 1. So board 3-1, that is board 3-0, this is board 3-1, because we are pointing to the 4th row and the 2nd element. So you always have to keep in mind arrays start at index 0. Pretty much get that into your mind for computer science. Most things start at 0, not 1. Like Americans tend to think of the first floor as floor 1, but I hear other places in the world think of it as floor 0. Okay, so now we'll go to an example. I have an example here. Here is a 10 by 10 matrix. We're going to create this 10 by 10 matrix. Okay, all cells will be 0 except for the border. So we're going to make this like a picture frame. So we're going to have 1s in the initial row, 1s in the final row, 1s in the initial column, 1s in the last column, and all the other locations will be a 0. So when you are creating arrays, of course you want to set a size for your array. This way it makes things a lot easier to modify and maintain. So you create the size of your array. Then you declare your array. We'll just call this a matrix. And the number of rows is 10 and the number of columns is 10. So it's a 10 by 10 array. It's 10 by 10 2D array. The easiest way to populate a 2D array is with loops. We should use basically 2 for loops. It makes things easy to use for loops. So we have a nested for loop. So we're going for int I, starting at 0, going to size, and then the inner loop is int j, going from 0 to size. When you think about this nested for loop, your outer for loop is always considered the rows. The inner for loop is always considered the columns. So let's look at the example up here. So we're going to start at row 0. So we're starting here, and then the inner for loop starts at 0. That one is the columns, so we're going to start here at 0, 0. Then we're going to go to 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 6, 7, 8, and 9. Then when the inner for loop ends, we're going to drop out and we're going to go back into the outer for loop. Well, I is completely finished now at location 0, so we're going to bump I to 1. And then we're going to jump back in the inner for loop and go column 0, column 1, column 2, like that until we get to the end of our for loops. So how does this look? The outer for loop from here to here is I equals 0, I less than size. We don't want to go to size, we want to go to 1 less than size, because indexes always start at 0. And we're going to increment by 1. The inner for loop, we're going from 0 to size minus 1, and we're incrementing by 1. Now what is I referring to? I is referring to a row. So if the row happens to be 0, or the row is the last row in the matrix, which is size minus 1, again it's not size, it's size minus 1, we're going to write a 1. So basically, if we're on this row, this row, or this row, we don't care the j value, we're going to write a 1. Else, we're looking at the columns. If we're in column 0 or column size minus 1, so if I cannot highlight the columns, but if we're on this column right here, write a 1, or we're on this column, write a 1. Otherwise, write a 0. So this is your basic if then else if statement. Okay, is that clear? If it isn't clear, keep thinking about this and replay the video. So when we print out the matrix, printing out is going to be easy. We have the inner for loop and outer for loop. We have the nested for loops again. But here it's easy. All we want to do is print out the contents. So the outer for loop is I, remember, referring to rows. I is 0, I less than size. Inner for loop, j is 0, representing columns. J less than size. And print out matrix of ij. And then an endl after every row has been printed, right? This prints out the column entries. So we want to add a carriage return or a line feed after we print out the contents of a row. Now, we'll get to this, what happens when we access out of bounds. I'll show you that. But right now, let's debug this. I'm going to set a breakpoint right at line 35. Okay, my program has stopped right here. I'm going to step over. I'm going to press this button. And now, my I is starting at 0. My J is undefined because I have not executed this line yet. I'm going to step over again. J is 0. Now, I'm accessing matrix IJ. Well, I and J, they're both 0, right? So we're accessing this particular one right here. And watch how we step through this. So, we're going to write a 1 to matrix IJ. So here's the matrix. Here's row 0. We have just wrote a 1 to row 0. Now we're going to step over. And we're going to go to J sub 1. We're going to increment J to 1, right? Now we're going to step over, and this, if it's false, oh, we're still in row 0, so this is still true. So let's just get through this one row. The first row, they're all 1s. We're in row 8, column 9. Okay, now we're going to go to the next row. So we've incremented our I value. Now we're going to step over. I is no longer 0. We're going to fall out of this. We're going to hit the else. But J is 0. We're going to hit this. We're going to set to 1. We're going to go and increment J to 1. Well, I is not 0. J is not 0. So we write a 0. And we're going to continue in this fashion until J is 9. So let's go to 9. J is 8. J is now set to 9. We're going to write that 1. So let's look at this. So here's our matrix so far. So we've got a row of 1s in row 1. In the first row. In the second row, we have a row that has 1s at the first column and the last column. Well, we're going to continue in that fashion until we finish. So I'm going to remove this breakpoint now and set the breakpoint here before we start our print. So I'm just going to continue until the next breakpoint. And it's a pity it doesn't allow me to see what matrix is right now. But I will just run through this code and we'll see. Here's the next breakpoint. We could look and see to make sure everything looks correct. So let us look at our output. So we have 1s in the first row, 1s in the last row, 1s in the first column, 1s in the last column. So we've accomplished our task. Now, going out of bounds, watch what happens. I'll step. I'm out of bounds. I'm size, remember? Size is 10. I've already used my 10 elements. I'm going to the 11th element. But, as you can see, I didn't get an error. I didn't get an error at any of these. So you got to be very careful. You will not get an error. I wanted to see where the error occurred, but I was getting anxious. So I just set it to 56, And watch what happens when I hit. When I try and execute the 56th element of an array which is out of bounds. I actually hit step over. And notice how it looks like everything died. So, hey, look, I have an exception. Finally, I got an exception. Right here. So, eventually you will die. But you want to be very careful to never go out of bounds. So this concludes the video on 2D arrays.